Well, obviously, we're going to wait for some people to show up. I'm so excited about these new reactions on my laptop.
Hello.
Oh, hey, Paul.
What do we owe the honor of AD presence?
Exciting.
Making
The
sure
eyes
we're
too.
not going to wander off charter.
The telechat's over, so he's got free time. This is great.
Yes, have to get over for documents of like 600 pages of Yang modules.
All right. Well, we give people another couple minutes. I think we had about 7 people that said they can make this meeting, and there are additional people that didn't fill out the thing, so there's a chance we might get a couple more. The doodle. Mm-hmm. All right, we'll give it till 5 after. Looks like Nick's having some problems. All right, well, it's 5 after. Let's get this show on the road. We don't have that long of an agenda, so probably won't go 2 hours, which might be good. But welcome. This is an official meeting of the IETF, so let's start with the process. We've got some note well here. This is the policies and procedures that govern a bunch of things that you should note well before participating. A lot of this is about IPR, and the basic summary is if you know something, say something. If you have any questions about any of these policies, please let us know. There's some other policies in there about any harassment and code of conduct and the like, but we'll talk about those next. And the note really well. This is about keeping it professional and making sure you treat everybody with respect. If you don't think that that's happened, you can come to us, an AD, the Obuds person. It's a whole bunch of good stuff in here that you should read. And remember, again, you don't have to love somebody's idea, but you should really try to love them. I'm going to kind of summarize that slide from now on. All right. And our agenda, we're going through most of this. Got note well, the note really well. We do need a scribe before we continue. Is somebody willing to get in the Meet Echo note tool up there and start taking notes? I already pre-populated it with our agenda. So all you have to really do is fill out, we don't need a word by word, play by play, blow by blow of the minutes. Thanks, Conrad. Yeah, we basically just need, what happened and any decisions that got made. Then I'm going to do a quick PSA for a public service announcement for it's now draft IETF MLS combiner draft. And then we're going to talk about extensions. And Raphael, I saw your agenda item proposal to go through the issues and PRs with respect to MLS extensions. And we can totally do that because I think we'll have the time. But this is basically it. So there's one big topic, which is really MLS extensions. And then we're going to get into Brendan's subgroups as well. He sent some slides. They've been posted. Richard?
Yeah, just as a point of order on Raphael's point, I would suggest we do the extensions discussion, extensions plus absent thing, then we do Brendan's draft, and then we come back to any issues and PRs in the remaining time.
Okay, that's good. I think that'll also keep people on the call for as long as possible. So that's good. All right, cool. So again, we got a scribe. We're going to get ready to go. Nick, are you back? Yeah, he might be having some troubles. Anyway.
Yeah, no, I'm here. Yep.
Okay, cool. Great. Just checking. All right, cool. So let's get into this. Richard, I've uploaded your slides, so you ought to be able to do these.
Did you have a PSA about?
Yeah, sorry, you're right. The PSA is real quick. Is that they're getting ready to release the initial draft of the combiners, the MLS combiners draft, and they've spent most of their time updating the security sections, security considerations, and the like. So if you have any other comments on any other parts of the document, please go ahead and throw those issues and PRs in via the GitHub repo. Thank you. All right. Over to you, sir.
All right, you're going to pull up the slides, or do I need to do that?
I think you can do it. If you can't, let me know.
If I can do this. Ask slides.
So I'm going to click like yes. And where do I say yes? This is always the fun part. Like I can see the button, it pops up, and I'm like, all right, I can hit an X. No, what the hell? I never did figure this out. No, all right, screw it. I give up. Too hard.
All right. So, good morning, everybody. Afternoon, whichever time zone you're in. This little deck is going to be proposals for some changes to MLS extensions, which came about due to, which I think we just did. We discuss this in the last interim, Sean? Remind me. I think we did. So I may be able to breeze through some of the background here. Next slide, please. There we go. So yeah, I apologize if there's some repeat here from the last working group call, but anyway, we can get everyone on the same page in the new year. The insight here was, as of the last face-to-face meeting in Dublin, there was some increasing complexity kind of creeping into the extensions doc with things like intra-extension diffs and a lot of application complexity kind of seeping into MLS. So the insight here is that we've been kind of abusing the term extension. We've been using the word extension when we really mean application logic. So the proposal here would be to kind of reserve extension to mean something that modifies MLS. It changes how the MLS stack changes in software engineering terms. Like if you have an MLS stack and some application code calling into it, think that things that change the MLS stack are extensions. Things that use the MLS stack differently are application things. So in particular, there's a bunch of things that are in the extensions document and talked about as extensions are not extensions in this taxonomy. So things just related to exporters or reusing MLS cryptographic keys in other contexts or storing application data on the group context, those are not extensions. And so we need a new framework. Where this leads us on the next slide is to kind of creating a new application API to expose the capabilities of MLS. So there's a bunch of things that MLS does that are useful to applications. So, and I've misnumbered here, it should be 1 to 4 and 5 and 6. Right, so we've got signature keys, we've got PSKs, we've got HPKE keys, we've got exporters and encrypted data and authenticated data. And then we've got kind of more meta functions like the association of data with commits via proposals and group agreement on group context extensions. So in terms of in terms of the docs heretofore, the first 4 of these were covered by the safe extensions section in the extensions doc, and the other 2, the latter 2, were sort of what AppSync was after. And was trying to expose that functionality. AppSync was describing them in the context of as a synchronization thing, but it's really a little bit more general than that. So in AppSync-01, we tried to pivot and kind of actually just focus on defining an application API. Next slide, please, Sean. So yeah, in AppSync-01, we basically refactored the safe extensions text to change out the word extension for the word application component. The main, aside from just verbiage, the main impact of that is that instead of using extension types to do things like domain separation, we use a new type of identifier called component IDs. And one of the big questions outstanding is, how do we need to manage those component IDs? Can an application just make up whatever it wants, or should we have a registry, et cetera? But anyway, there's a separate namespace of component IDs, which we use for domain separation, separating data and data structures and things like that. So for the functionality that was covered in safe extensions, we just did that refactoring. HPK signature keys, PSK exporters, encrypted authenticated data. Then we added a couple new things to sort of correspond to what AppSync had been doing in the past. So to cover this functionality of associating data with commits, we added a new application data proposal. The idea here is that an application is using commits for it has to synchronize commits anyway, so that can be a useful synchronization point for other sorts of app data. And the way we can extend commits is with new proposal types. So here's a proposal that an application can shove data in. For the more sync-like, directly AppSync-like stuff, this group agreement stuff, we took the sort of extension that AppSync had defined, generalized it to be an app data dictionary and a corresponding proposal to update it. The nice thing about both the application data and app data update proposals, of course, is that they're only touching application data. They're not touching the MLS state, so they never need an update path, and so they can be used in small commits. Next slide, please. So what happened? Yeah, it's just a picture of the structs in case anyone's forgotten since December. Next slide, please. Oh, yeah, thank you. Rowan did a PR on AppSync in the last couple of days, trying to clean up the naming, make it more intuitive. So some of the names have changed. So what's really new for this call since the call in December is that the editors of MLS extensions and AppSync got together and tried to hash out a plan for what we're going to do with the extensions document. So there's basically two parts to this. Part one is to rework the safe extension section into basically the form I was just describing. So basically turn it into the, here's the application, the safe application API. So do that same reframing in terms of application components, component IDs, etc. Add the bits that are more like AppSync, that new proposal, the new extension. And then the one question is, there's a little bit in there about proposal developer guidance, generic proposal types with and without path. Let's try and make it easier for folks to make custom proposals, which would be legitimate extensions. That's kind of the main question mark as to whether we keep that, move it elsewhere. It would move out of this app API section, probably into its own subsection, or maybe we drop it if we don't want to keep it. It's my personal predilection, but I understand others feel differently. So that's the kind of refactoring bit. So rewriting the safe extension section to refactor it into the app API. And then there's the extensions in the doc. So there's like actual substantive extensions in the extensions doc. In this new framing where we reserve the word extension for something that touches the MLS stack, not all of these things are extensions. And I'll discuss in the last slide. So some of these things are extensions in this new stricter framing because they actually change MLS behavior. Others of them are more properly described as application things. The term we settled on the author's call is reusable application components. So these are bits of application functionality, but they're things that are reasonably common. So different applications might all want to use them. This will become abundantly clear on the next slide where we talk about some examples. So we kind of want to make a pass through the actual extensions. Some of them will remain extensions as they are. Some of them will get recast as reusable application components. And then as we were looking at the extensions that are in there, there's some in there that seemed like they might need further discussion or might not belong in this little omnibus extensions doc, might need their own docs. So we might pull them. So concretely, on the next slide, please. When we went through the extensions in the doc, this is kind of the plan that we ended up on. So AppAC, for example, makes sense as a reusable component, an application component, right? Because this is the application talking about what messages it has received. And so that's not touching the MLS state machines, not touching the core MLS guarantees. And so that is safe to redesign as an application component using the application API. By contrast, targeted messages is changing how things like content encryption work, and so it would need to remain an extension. Content advertisement is currently framed as an extension. I think it probably goes up into the app API as kind of here's how you frame the encrypted content if you want to do that safely as an application. Self-remove, obviously changing MLS protocol semantics, so that needs to be an extension. And the last resort key package, obviously that's application semantics because MLS doesn't know anything about last resort key packages, and so it's safe to be a reusable component. And the final two, I just wanted to also mention some other drafts that we had, that this group had discussed folding into the extensions document. Additional credentials, actually both of these are to do. Additional credentials, that is defining additional credential types. Obviously the MLS stack needs to at least know how to handle those credential types, so it needs to be an extension. And likewise, associated parties changes how some secrets flow would need to be an extension. So that's the roadmap of how we, the author team, are thinking about updating the extensions doc. Not big content changes here. Mainly it's just reframing and making things a little more generic, putting things in sensible bins. I think we had discussed previously putting in additional credentials into this document. I think that's still a good idea. I'll probably send a PR to do that. So we just wanted to put this in front of the working group before we started filing a bunch of PRs and doing some pretty invasive edits on the document. I think overall the feeling is, given that these are mainly clarifying changes, not really substantive changes, we should be able to kind of get the document tuned up and hopefully finalized in fairly short order. There will be a bunch of content changes. You know, the edits here will be invasive in terms of words, but not in terms of content. So hopefully it will not dramatically change people's evaluation. So I think we're hoping to have these edits in the next, I don't know, couple months. Maybe if we move with alacrity, have something that might be ready for a working group last call in sort of the March IETF timeframe. So on the last slide, that's all we have. So yeah, if anyone is, so really, you know, if we are agreed on this plan, you know, if you have concerns about this plan, speak up now, because the author team is fixing to go make these changes. If not, we'll go do it. If you are enthusiastic about this and would like to help contribute, we would love to have more folks taking a look at this. And so let me know. That's all I have. Anyone have thoughts, questions, concerns? Think this is awesome, think this is terrible, etc. Silence is consent.
Yeah, I'm not seeing a queue. All right, Raphael, there you go.
Somebody had to say something. Yeah, just wanted to note that it seems that Ron has already started doing PRs for the AppSync 01 stuff towards the MLS extensions document. Just wanted to clarify that that is already happening.
Yep. Just looking at the participant list for folks who this might be new to. Deirdre, Brendan, Mark, Paul. Does this all seem clear and practical? Good idea. All right. I'm assuming that's yes in the chat from Brendan. Great. All right, cool. So we author team, you know, we have delivered on what we promised in the last interim. We will start going make some PRs now. All right, that's all I got for this one.
All right, cool. I will take it over to Brendan.
Hey, Sean, can I actually drive?
Are we all still there?
Hello.
Yeah, sorry. I think if you click share slides, which is like the fourth button over, I think
Okay.
it says that, and then I kind of like, every time I see this, I'm like, what button do I click to make it say yes? I can see an X, but I can't see a yes. That is really annoying. Literally, like I see an X and I see as asked to share slides. I'm like, maybe it just happens, or is it timeout? No, it looks like it's going to time out. That's so annoying. I don't know what I'm doing wrong here. Alrighty, let's just do this. I'm going to run this. If I do that, is there any, can you click through this? Do you see the arrows on the bottom?
No, I don't. You can drive though. It's fine.
Okay, all right, cool. Fine. Sorry about that.
No worries. But yeah, so I wanted to present a draft that I wrote kind of a long time ago called MLS subgroups, basically because there's two essentially competing drafts that are in the working group right now. I've driven slides many times. I don't know. I think it's just like a UI issue is complicated.
It might
yeah.
be it might be operator error as well. So
But yeah, there's two competing sort of drafts in the working group right now, and I wanted to talk through this to kind of get my merits out. But yeah, next slide, please. So this is generally how we've thought about sort of MLS groups and the MLS working group, is we just have one big group, and rather than the members of this group being some concept of a user, uh, the members of the group are individual user devices. So the membership list is going to be like Alice's phone and Alice's laptop and Alice's second phone, and then Bob's phone and then Bob's laptop, and so on. Um, next slide. The reason we did it that way was, I think, kind of a simplifying assumption for writing the protocol document, but from an application perspective, um, there are some downsides to this approach. So the first is that consistency is relatively expensive. And by that, I mean just making sure that every user's device is in every group that, the quote unquote user is in. So rather than just having like one list of authorized devices, we have our list of authorized devices. And then we have to go through to every group that the user is in and make sure all of those devices are in all of the groups. And I've actually worked on systems before where every member of a group is constantly refreshing everybody else's authorized devices to see like, oh, did Alice add a new phone? And maybe her other devices are offline. So I need to add Alice's phone to this group for her, which is obviously super expensive because everybody is constantly refreshing everybody else's authorized devices. It's a quadratic number of network requests. And then on top of that, the privacy properties are not very good because everybody can see everybody else's devices. I can see that Alice has a phone and a laptop and a second phone, and I can see when she, changes her devices. And actually, on top of that, I can also see which device Alice used to send specific messages, which is not great and not something that you would usually think about wanting to share in a messaging context. Next slide, please. So this draft proposes moving to a model where instead of having one big MLS group with all the devices in each group, we have essentially one MLS group, and in that group is just the user's devices. And this is called the subgroup. So in Alice's subgroup, which is her devices, she'll have her phone and her laptop. And then these devices together through the MLS group control a virtual client. And then that virtual client gets added to sort of real groups with other users, and these real groups are called super groups. And we want to do this in a way that preserves preserves the security properties of MLS, but also is operationally simpler and provides better privacy properties because we don't see necessarily everything that happens with someone's authorized devices. The subgroup is more of an identity bundle in the sense that it's just an MLS group, which is all of the users' devices. You wouldn't think of it as like a subset of something. It's more so just a fun word because we have an MLS group, and then we have the MLS subgroup, which is just me. But that's where the name comes from. So next slide, please. The main issue to actually doing this, of having some set of devices which control a single virtual client, is generating private keys. Exactly, thank you, Richard. But yeah, the issue is generating private keys. The two places in MLS where we need to like generate ephemeral private keys and like share that is in key packages and in leaf nodes. And the properties that we kind of want from how we generate private keys is, one, we want it to be coordinated. And by that, I mean every authorized device can recover the private key. So I might, not generate a key package, but I see this key package exists and it's from my virtual client. So I need to be able to compute that private key that goes to it. And then the second thing we want is we want it to be forward secure. So I'm sort of consistent with the main MLS security properties. I want to be able to generate the private key in a way that I can delete some stuff later and not be able to get that private key back. And also post-compromise secure. So if like a malicious device gets added to my account, once I remove it from my account, private keys generated after then aren't going to be accessible to the malicious device. I forgot to write that, but yeah. And then the third is consistency. And I don't think this is a great word for it, but essentially trying to capture the idea that things work over a long period of time, because there may be a long period of time between when one device generates a key package and when some other device needs to recover the private key for that key package because it was finally used or whatever. So devices may not be time synchronized. They actually are definitely not going to be time synchronized, because one device is going to generate a key package. It's going to go sit around for a long time. Several epochs, a lot of time will go by before that key package is actually used, and we need to be able to handle that. So next slide, please. So the draft proposes is that in this subgroup, which is the group with just the devices, we export a secret from each epoch of the subgroup. So essentially each epoch of the subgroup reflects changes to the membership of the user's devices, and then from each epoch in the subgroup, we export a secret just with the usual like MLS exporter code. And next slide. With that secret, you essentially build a secret tree like we do in the main MLS draft. So from this root secret, you derive 2 children secrets, you delete the root that you used to derive the 2 children, and then you retain one of them. That's the filled in one that's filled in black on the right here. You retain that one, and then you recurse to the other one. And then next slide, please. So you kind of keep doing that of generating 2 secrets and deleting one, and doing that until you have a tree that's as big as you need. And then each leaf node of this tree ends up being the seed for generating a certain private key that you need. So this is coordinated because I can say I use this leaf of the tree to generate this private key, and any device which was in that epoch of the subgroup can compute that same private key, but it's also forward secure because we can delete the intermediate nodes of the tree, and then once we delete that last P0, it's gone forever and we can't get it back. Rowan? Did you have a question, Rowan?
Sorry, I was just struggling a little trying to figure out what your, why you need a, is this tree, does this tree represent it's neither the ratchet tree in the main group nor the ratchet tree in the subgroup, right?
No, so this root secret of the tree is the output of the MLS exporter. So we export our own secret from the key schedule, and then we build this tree with it. It's separate.
Okay, and why do we need a tree there instead of using like PRFs or something to generate secrets?
Because we want to be able to do it in a way that's forward secure, so I can delete these intermediate nodes. And then once I delete P0, which is this last secret here, P0 is gone forever. And all that I'll have retained is these filled in black nodes that allow me to compute the rest of the tree, except for P0, because I've deleted it.
But in order for a client to be able to join, it's going to have to be, it will have to have to be able to generate the tree, right?
So when a new device gets added to the subgroup, it immediately gets the root secret for that epoch. And then there are also ways in the draft that we can send old trees from previous epochs to the new device, so that it can access old private keys as well.
Okay. Please carry on.
Okay. And then Conrad, you had a question as well?
Yeah, so I'm trying to understand, and maybe this is coming later down the road, but so forward secrecy is a nice property, of course, but then if you have other folks, other new clients joining the group, then they kind of need these secrets, right, to join the main groups that the user is in? Or am I misunderstanding something?
So there is secret state, or sorry, can you repeat the question?
So I think I'm gonna just try to summarize what I think you said. So we want from these epochs we export something, and these secrets are then used to derive the secrets in a forward secure way. The secrets in the groups, in the main groups that the user is in. Is that correct?
Yes, that's right.
And why? Oh, and you need them to be forward secure because in case you later update one of these leaves that you generated using one of these secrets, you want them to be forward secure so you can delete the kind of seed secrets. Does that make sense?
Exactly, yeah, because in
Okay.
MLS, it would also require you to be able to delete the secret that corresponded to the private key from some old key package. And so
Yeah.
we want to preserve the ability to be able to delete that and have it actually be gone.
Got it. Okay. And then the next question, this construction, is that looks very much like the puncturable pseudorandom function that Joel proposed at some point. Does that make sense? I mean, it's just a generalized version of the secret tree, essentially, that we have
Yeah,
already
it's the same
analyzed.
idea.
Oh, okay, got it. Thank you.
But yeah, so this is coordinated because everybody can follow along and compute their own private keys as they need. It's also forward secure because we can delete things that we don't need anymore and they can't be recomputed later. And then because we have multiple devices that are all potentially operating on the same tree, we have to worry about preventing reuse. So we don't want people generating the same private key and using it in different contexts. So what happens is we will basically allocate each device in a subgroup some subset of the leaves in this tree that they can use to generate their own private keys, and they know that nobody else is going to use those private keys for something else under them. Because one thing that we can't rely on is the delivery service preventing us from reusing private keys. Essentially, we can't rely on the delivery service to tell us someone else used this private key already, so you can't use it, because that would be putting too much trust in the delivery service. But yeah, next slide. So that's how we do it in a coordinated way and in a forward secure way. In terms of actually making this work over a long period of time without assuming that the devices are time synchronized, we need to be able to communicate to other devices in the subgroup where the private key for something came from. And how we do that is we just add an extension to the key package or the leaf node that we generated this way. And the content of that extension is essentially just an encryption with a fixed symmetric secret key that says, I use this epoch and I use this leaf to generate this specific private key. Any device which has that fixed symmetric key can decrypt that ciphertext. They can see that and then recompute the private key themselves. And of course, what's nice is because this extension is in a key package or a leaf node, it can be safely ignored by clients that don't implement this draft. So they can just ignore it. They can be completely unaware of it. Next slide. So generating private keys was the main issue that we had to solve, but there was actually a secondary issue. So the secondary issue is that since the MLS key schedule deterministically computes the key and nonce that we use to encrypt each application message, and we have multiple devices operating off the same key schedule, it could happen that multiple devices could try and reuse the same key and nonce to encrypt the same application message. And if you use the same key and nonce with different messages, that is bad for the cipher, they say. Next slide, please. So the solution to this that the draft has is relying on what's called the reuse guard. So the reuse guard is something that's part of MLS, where when we're encrypting application messages, we generate 4 random bytes. Those 4 random bytes are XORed with the nonce before the nonce actually goes into the cipher. And essentially the observation here is that if we guarantee that all the different devices will always choose different reuse guards, nobody will ever use the same reuse guard, then that means that there's no nonce reuse. So, one simple way to do this would be to just like have a prefix on each reuse guard and say like all the reuse cards generated by this device will start with 0. All the reuse cards generated by this other device will start with 1. And then we'll know that there will never be nonce reuse because the reuse card will never be the same. The only thing that we want to do there is that we want to prevent leaking the sender. So we can't have the reuse card just be transparently prefixed with like a device identity, because then that would leak which device sent it. And the solution there is you just take that same idea of device ID concatenated with the rest of it is just random bytes, and then you pass it through a pseudo-random permutation, and that's your actual reuse card that you use. Yeah, it's 2 to the 32 devices. Once you have 2 to the 32 devices, there are no bits of randomness, and that's not ideal. But yeah, next slide. And so in conclusion, basically this draft explains how to use multi-device MLS without leaking a user's device set or which device is currently in use. So that's good for privacy. It also simplifies the operational aspects of multi-device because all of the user's devices are maintained only in one group. And it does this while preserving the original security properties of MLS. But the important thing here is that it doesn't require changing the wire format of MLS. So it's compatible with existing implementations that don't implement the draft for free. And also it avoids potential downgrade scenarios where if I am a client that implements this draft and then I join a group where a client doesn't implement it, I don't have to like downgrade and lose my privacy protections or like fail to join the group or something like that. But yeah, Conrad.
I think so. Recalling the discussion we had last time, because we had these kind of two somewhat competing, but also quite similar, maybe unsurprisingly, quite similar approaches to this. And the point where we had the different approach is not the nonce reuse problem, which you solve quite elegantly with the reuse guard, but the key reuse problem. And that's like not the security problem. That's the kind of a functionality problem, where the recipient has potentially already received a message with the same key but a different nonce, but it's already deleted the key because of the deletion schedule of the secret tree. And so I think your proposal back then was that the DS should keep track of this and ask the sender to resend the message under a different key. Is that still the proposed solution, or did you like, is there a new one?
Yeah, that is still the proposed solution, is essentially that the DS, because this is really just a functionality issue, is the DS would hopefully give you a view of which keys have already been used, so you can not reuse them and people will be able to decrypt your messages. The reuse guard, the preventing nonce reuse, that's about preserving security.
Right. But how would so this means that the DS has to be aware of this kind of scheme, the use of this scheme. So it's not, so it doesn't maybe change the wire format, or maybe a different question. How does the DS know which keys were already used? Like, how would you detect this?
The DS has to send you other devices' messages so that you can see them on your device. So we might have a message that was sent from the virtual client Alice by one device, and then in my head, that is getting sent back to all the other devices.
So the DS has to be aware of this whole thing anyway, right? So
the DS has to be aware there are multiple devices that receive the messages sent by one client, yeah.
Okay, so you'd have to work around that a little bit at least, because you know messages could cross on the wire and stuff.
Mm-hmm.
Okay, fair enough. Thanks.
Thank you.
Yeah, I have a follow-up question regarding that. So I think the nonce reuse solution is really elegant, but I'm still not entirely sure I understand exactly what we're imposing on the DS. And before we go into that, you said that it's only a functional problem, but I think if we modify how the deletion schedule is supposed to work, it's more than a functional problem, because we might exclude clients that are not aware of that at all by maybe rejecting their messages or something. So yeah, I'm just wondering if we're like technically changing how the protocol works or not.
So I definitely wouldn't propose changing how the deletion schedule works. I still think it should work that if you receive a message encrypted to a key, you should delete that key.
Right.
The requirement on the DS to make that work, though, is that other devices can generally see when another one of their own devices have sent a message using that key.
Right. Okay. I see. So everybody deletes, but if say one of the devices generates a new message with a key that has already been used, that gets rejected by the DS, and that can only happen by a client that is actually aware that there can be a rejection. It cannot happen to a client that is not aware, that doesn't know anything about subgroups, right?
Essentially, yeah.
Okay, I guess that makes it okay, but so does it mean that the DS needs to know exactly how many devices are in a subgroup, or like what is exactly the requirement here?
I don't think the DS needs to be highly aware of what's going on in the subgroup, like how many devices and stuff. Because you could have just like a generic model where there's an MLS group that has like an identifier, and then people come and subscribe to receive all the messages sent to that identifier. And that would actually work fine for this, because a device, all the different devices that control a virtual client would subscribe to the same identifier. They'd see all the messages that are sent to that broadcast channel. And that would already suffice for preventing this from being an issue.
So essentially, the DS needs to remember. So a key is tied to a generation, I guess, to an epoch and a generation and a sender. So
Yes.
that's the combination that the DS needs to remember for a given epoch, and then it can probably flush that if we don't allow like cross-epoch talking.
Mm-hmm.
It would be interesting, yeah, to sort of flesh out what the bare minimum is that the DS needs to track here.
Mm-hmm.
I think that would be helpful. Yeah. Thanks.
If I may jump in here. So I think that if let me know if I understand correctly, but the DS at least needs to kind of mirror the application message back to the sender, essentially, right? And then it would go to all the other clients of the sender, and then they would know not to reuse that key.
Not necessarily. I mean, we're getting more into like network topology questions. It doesn't like.
Same as Raphael, I'm just trying to understand what the requirement is for the DS.
Mm-hmm.
And
so from the network perspective of like where messages are going over the wire, I would think of it sort of similar to how we thought of the original MLS group, where we have one big group and all of the devices are all individually receiving the messages that are sent to this group.
including the sender itself.
The device that sent a specific message doesn't need to receive their own message back.
Right, but in the context of the
don't
big
think-
group, there is only users, right? So
Yes.
so if I send a message to that group, the DS somehow has to decide to whom to forward this message.
Well, yeah, that's what I'm saying, is the member of the group in the MLS state is this one virtual client, but on the network level, the messages get sent to each device. So we might receive, one message from quote unquote Alice, but then that message is sent by Alice's laptop, and that message gets sent to Alice's phone and then Bob's phone.
So then at least the DS would have to know which device exactly it came from.
Yes, but I don't think that that's necessarily a privacy leak, because the DS already, the DS is already responsible for managing all of the connections to the subgroup, to the supergroup.
Well, that depends on the topology. In a federated setting, that's not necessarily the case, though.
Okay, yes, that's true.
Okay, good to understand. Thanks.
Hi. I wanted to know, I think in general, I think for things like this, it's kind of hard for me to figure out what I'm evaluating against. And so like having something near in the introduction or like toward the beginning of the draft that just says, here are the properties that we think that this thing has, and here, like here are the requirements, and here are the additional properties that it has. So that could be like 6 to 12 lines of or bullet points of but the particular thing that I keep thinking about is the timing of if I have a client that is if a client isn't in my subgroup is sort of abandoned. I'm trying to reason what the properties are, the security properties are in that case, and when it loses the ability to get messages from the group, if at all. And yeah, without having some kind of like, this is what we think this should do, then it's hard for me to to get an idea of how that would work.
Okay, that's helpful. Thank you. Generally, I think the dynamic that we're going for is that the authorized devices are the MLS membership. And so a device loses the access to, a device in a subgroup loses access to the supergroups once it is removed from the subgroup. But I'll write that down for sure, because that's complicated. Raphael.
I got that. It was more like, what do you imagine would be what would happen, that like sort of more the steps of how does that happen in a way that preserves PCS?
Mm-hmm.
Yeah, I was gonna say something else, but I think, Ron, you're right. Of course, that stuff is complicated. I just want to make sure what we're discussing today. So I think, Brendan, if I understood correctly, the idea was to narrow down the differences we have between the two competing proposals. And if I understood correctly, right now there is only one difference left, and that is how we deal with the encryption of application messages, or more generally, private messages. Is that correct? Or do you see other differences too?
I mean, the encryption is a big thing, but the defining, like, the tiebreaker in my mind was not changing the wire format of MLS. So that's
right. Okay, that's part of that conglomerate. Yeah.
Yeah.
Exactly. So yeah, just to remind folks. So in the other proposal, the idea was that we introduce essentially a new wire format that is very similar to existing private messages, but we avoid key reuse by using a PPRF. So technically, it's not compatible with existing private messages. So that's the big downside. You cannot mix actually like vanilla MLS and that concept. The upside is it's the only change, and you can run it over a regular DS without imposing any additional requirements on the DS, which potentially can be a huge upside. So this is again why, in my mind, it really comes down to what exactly we're imposing on the DS. And so far, I think I've convinced myself that it's enough if the DS has like a per epoch hash set, where it essentially like you can take the sender and the generation as an input, and if that has already appeared in the epoch, then a message is rejected. If not, it's fine. And if that's really the only requirement, then that's probably sort of reasonable. If it's more, then we really need to understand what it is.
But then doesn't that change the wire format? And we're back to the beginning. You need to kind of to attach information.
Oh, because because the sender is not visible in a private message, is what you're saying?
Neither is the generation.
That is a good point, yes.
I mean, if it was only if we only needed to get the information to the DS, then that would be okay. It's only if the information needs to arrive at each of the clients in the main group, then that would be a wire format change that we care about.
Are you saying that you want to use semi-private messages to solve that?
No, I'm just saying that you could attach some information separately, like the way that people were talking about having AAD that's not attached. You could do that to communicate to the hub, to the DS, if you didn't need it to get all the way to individual clients. Clients didn't need to act on it.
Right, you could like loosely attach it. That is true. And not put it in the AAD or anything else. But yeah, but then again, you could also use semi-private messages. I think that would do the trick, actually. But maybe Brendan had an idea of how to solve that specifically.
I think if you kept the stuff around, that would also prevent the leak that you get in the federated case. Because then the other clients, that the DS doesn't have to let the other clients know that one of the clients has sent a message with a specific generation, I think.
Sorry, can you repeat the last part? Keeping what around? I'm not sure I follow.
So Brennan has to correct me if I'm wrong, but I think the original approach was not to have a hash set on the DS to prevent this kind of key reuse, but instead to just forward application messages to distribute application messages to the other clients of the sending client, like the other clients in the same kind of user group. And then they won't use that key anymore. But in a federated setting, the DS doesn't necessarily know the other clients. And so you'd have to leak that to the DS, which...
Yeah, okay, I see what you mean now. But yeah, exactly. I think that's exactly the point. I think it would be an unreasonable demand to ask, the DS to be able to quickly forward stuff and understand, what to forward and to how many clients, etc. And generally to have knowledge about the subgroup. That's why I was coming up with the hash set as an alternative.
But I'm not sure, Brennan, what do you think? Do you think, like, I would think you wouldn't have to put that in the document specifically how the DS is managing that, but you could just say the DS has to somehow prevent these key reuses. What would be your take on that?
Well, because it's not a security issue in terms of reusing the key, if we're not also reusing the nonce, it's just a functionality issue. I don't think that I would say the DS must solve this. We could say the DS should solve this, but the way that the DS solves it is application layer, essentially. Like in some applications, we could do what I was talking about, where the DS is aware of all the devices behind a specific virtual client, and the DS bans them out, like I was saying. Or in the federated use case, we could do something else. But in both cases, it's an application sort of layer decision, however you want to do it.
Right, but it might still be helpful to give some examples. Like
Mhm.
the initial example would be, like you said, the DS needs to fan out messages to all the clients in the subgroup so that they understand they cannot reuse that key. This might work for some applications, and for other applications, it would be okay if the DS just blocks messages that reuse a key. But for that, it needs to have some knowledge about that, and maybe semi-private messages, or as Rowan pointed out, loosely attached, metadata to the message might be enough. But it would definitely help to have some, concrete ideas of how this can be solved, and not leave it as at a hand wavy stage, because that's probably then not good enough to go forward with it.
Yeah, we can add that to the document. Some examples of what you were talking about.
And because ultimately we might also consider this for Mimi, and there might be some hurdles, but I think it would be a good benchmark for such a concept.
I mean, ideally for Mimi, it would just, sorry, I should put myself in queue. Ideally for Mimi, it would, the rest of Mimi would be oblivious, and it would just be an optional thing that your provider can do. But the federation issue is a big issue for Mimi, right? So we wouldn't want this to be something that you would need to implement on every provider. And the question would be, if it was your hub provider didn't support it, but your client, but your the sender's provider did, would that still work? That would still be valuable. So that would be an interesting analysis for use in Mimi.
Yeah, maybe we should bring this back to the Mimi working group and see what the kind of discuss this Mimi internally. But yeah, I agree. I think this would be great to have in Mimi. But as you say, it would have to be. It would still have to work for folks where providers that kind of rely on this feature to manage clients. Would still have to work with other providers that don't necessarily support this feature. So yeah, we'll really have to think this through.
Okay, so what I heard was that there were going to be some revisions made to the draft, and then you're gonna take it over to Mimi for discussion.
Yes, that sounds right.
I think we should still discuss it in MLS until we're like, yeah, this is what we like. But then, yeah, even if that's the same meeting, we can still talk about it at Mimi as well.
All right, cool. That's good. I just wanted to make sure we got some clear goals and direction for Brendan. Okay, great. Unless anybody else has anything to add here, we're gonna go and do some GitHub diving. All righty. Stop the slide, share the screen. Let's see if I can I want to screen share? Yes. I would like to share a window. How about share a window? Let me pick this window. I'm going to share this window. I think I'm in the right place. All right. Let me know where you would like me to go.
I guess we can start with the issues.
Okay.
Let's start with the last one. So the two last ones, I think they're specific to targeted messages, and Richard already alluded to that. The question here is whether we want to keep that in the document or make it something separate. The reason being that there were some ideas to extend it quite a bit in terms of functionality, and that it might just take longer. And so it, as an item, it sort of stands out compared to the rest. So that might be the motivation. So I propose I can take care of these two issues once we decide what we're going to do with targeted messages.
Okay, that works for me. Can you repeat the last part? We'll take care of this once we decide what to do with what?
What to do with the targeted message extension.
Message extension. All right. I guess I should. Right,
and then same for the next one.
Okay, I'm going to cheat now. There we go. Let me update the comment. Go put this in this one. Oh, look, I can even assign it. Okay. I'll go back and self-remove.
Right, so there is an open question. So good you're still here, Ron. This is really old, by the way. It's from 2023. So I think we're talking past each other here. I think Ron's concern was that if Alice has multiple clients, then the self-remove would only work for one of the clients. And I'm suggesting that she can just remove all of her other clients first and then do a self-remove with the last one. But apparently, we're talking past each other. Maybe you want to explain, Ron.
I was just saying that there is no atomic removal in Shirt, right? So I think the desirable property, the most desirable property would be that we have some way to say, okay, all of these things happen at the same time, and they work if you have an external, if you have an external committer. The mechanism, like basically what's written into Mimi right now, is that you send what will become a app data update proposal, removing your user from the participant list, a self-remove for your own client, and removes for any of your other clients, and you send them all at the same time. And then the idea is that a member committer will commit all of those things all at the same time. But if you have a self-remove and the self-remove is allowed to be included, but the removes are not, then you're going to be in the awkward situation where you're removed from the participant. It's going to be invalid, right? Because the client that actually was online that could go do the work is not, so you'd have to do a two-step thing, which is super awkward from a UI perspective. Kind of like some of the same issues that Brendan was talking about in the previous presentation.
Okay, yeah, got it. So yeah, it's definitely not atomic. What I was proposing is to sort of make it de facto atomic if you have an architecture that you sort of control. Of course, in Mimi, it's a lot about agreeing on stuff and federation, etc. So that's definitely harder to pull off here. Now, we could also argue that having virtual clients would definitely solve that problem, because then you remove one user and not individual devices anymore. So this is actually a very strong argument for using virtual clients. But so what I'm not sure on, Ron, is do you want to propose a change here to self-remove, or was it more of a philosophical remark at this stage? How do you want to go forward with that one?
So I had proposed at one time a generic MLS extension that says pending proposals are on this particular DS, pending proposals are stored on the DS. And if you get a group info, you're probably getting it from the DS, and you need to get all of the pending proposals at the same time and commit them. So there is the problem that you can't validate those proposals, but we could go and, we could use some mechanism to solve that problem and bundle the two together at some point. If we did that, we won't need self-remove. But what I'm inclined to do right now is just note that this is a potential issue in environments where there are lots of external joins and our external commits, and we just move on. Basically, we just hope that that we code the right things in the implementations, so work around this annoying problem until we have a better solution, like a general solution to that problem. So we go ahead with self-remove as is. Hopefully in the future we have a better solution.
Right, okay. So, I mean, what you're proposing is maybe even a little too general, because you would only have to generalize in the sense that remove proposals would be acceptable in an internal commit. You don't necessarily have to honor updates and adds and stuff, which might be even harder to check. But okay, then, yeah, let's follow that idea, and we can close this for now, also because we want to see if we want to use virtual clients, which would entirely solve the problem, and then the current self-remove would be good enough. And then we can come back to that if we need. Conrad.
Well, generally, I'm a fan of virtual clients. This might still be useful for people who don't want to use virtual clients, because there are legitimate reasons that you might not want to use virtual clients. Just saying that we shouldn't, bet everything on virtual clients and then say, just use virtual clients, everyone.
Oh no, I meant specifically Mimi, because Ron brought Mimi up.
Fair enough. Okay.
So does that work as a note to close this out?
Any objections from anyone?
Going once, going twice. Rowan? Or are those phantom? No, those are phantom. All right. I will close the comment. We can always reopen it later. All right. Going on to number 24. All right. Benjamin is not here.
Is it just me, or is the screen share not updating?
Let me see. Is it not? Oh, it might not be updating. That is weird, because I went in a different window. Apologies. So this one's closed. And I'll go to 24. Thanks. Thanks for letting me know. There we go.
Okay, so we have this one from Benjamin, who is asking whether we should have an extension to signal if a DS does like strong or weak ordering. So far, nobody has reacted except for Brandon. Said he's not sure we need it. So I propose we close that until somebody has a concrete need for that.
This is already mentioned as well in the Mimi policy stuff. So like I've got something that looks like it's a list of the stuff that's in operational considerations of MLS architecture, with a way to say like, hey, this is the policy on the DS. This is the operational policy, FYI. So it would become part of a bigger thing.
Right. I mean, my hunch here is that an application has to know ahead of time anyway how an MLS group works, like how a DS works, because it'll probably talk very differently to a DS that does weak, ordering, because that DS doesn't even exist as a server anymore. So, like the whole architecture would be completely different.
All right.
All right.
Let's do it. Close. Pull up the next one. No, I just did that one. 30.
Another one from Ron. Yeah, handing that one over to Ron. I don't know if that is actually still up to date.
This will be solved. I mean, we'll have to go and refactor everything anyway when we do the current merge, right? So I'll take care of that at the same time. You can just leave it open and just put a note that it's that it'll be taken care of at the same time as the AppSync to MLS extensions merge.
Cool. Thanks, Ron.
And I'm gonna have to go mobile here, so I'm gonna lag a little bit in terms of reading things on the screen.
All right. Add wire format compatibility.
This one was from Richard. This might also be stale, but I don't know, Richard, maybe you want to say something?
I think this is still live. This came out of some discussions that we'd have about, I think An from Google had raised this question of having a wire format with detached authenticated data, which makes sense, would be another thing that would be nice to add to this doc. But it's impossible right now. That would require a new wire format, and it's impossible right now to negotiate support for wire formats. So I think this is still to do. You can leave it open and mark me as the assignee. Should be a short extra section in the doc. Conrad?
Cool. I wasn't sure if that was covered by the new AppSync stuff or not, but if it's not,
It is not. I think this would be an extension that. Yeah.
While we're at it, can we also add that for content type? Because
sure.
Because for example, as part of I think it was part of the associated parties extension, I wanted to send something to somewhere encrypted, and I would have to just reproduce the whole application messages thing, or might have been a different extension. But anyway, if I wanted to send something to the group encrypted, that's not an application message, I would have to, have a separate secret tree and that kind of stuff. So it would be really handy to not have to specify all the authentication bits and encryption bits that we already have in the document in another extension, just, copy paste essentially.
Yeah, agreed. Yeah, and if anyone finds extension points that we don't currently have negotiation on, please post a comment on this PR. I'll do the analogous stuff.
All righty. Updated. One more issue. Streamlive extensions. Yeah, so this is all going to get done with the refactor, right?
Yeah, this is going to get overcome by the refactor.
Do you want me to leave it open or close it?
Why don't you leave it open and we'll close it with the refactor PR. I'll file a follow-on right now about the generic proposals, which we need to make a decision on. But we can handle it as a separate issue.
All right, I'll jump over to PRs now.
Sounds good.
Okay.
So we have one from last October from Rowan. Placeholder group context encryption mechanism. That is a draft, and I'm also not sure if that is not covered by the new AppSync stuff. I don't know if Rowan cannot speak. Maybe Richard, you can speak to that.
I mean, I can speak. I can always speak.
I like that you do at the bottom. Replace this with something better. This must have been OBE, right?
Yeah, this does not seem like something covered by AppSync. I would say like it's a draft PR. I think that's the right status for it. I'd say it's on Rowan to do something with this and mature into something where it's ready for review.
Okay, so it's not covered by AppSync. That's what I was after.
Yeah,
Right.
that's correct. That's correct.
Okay. Let me
Okay,
just
so
let's do that. Covered by AppSync. All right, let's go to the next one.
maybe we can get back to that if Ron gets connectivity again at the end.
38.
Okay, another one from Ron with some change requests from Brendan on it, but yeah, this one's not a draft.
So this feels a lot like adding in multi-credentials that Richard did, right?
I was going to say the same, yeah. So Richard, again, is that stuff that is covered by the multi-credentials?
Sorry, I was talking to the mute button. Yeah, I think way back in the San Francisco IETF meeting, we discussed what to do with the additional credentials document. The feedback was to put it in the MLS extensions doc. So this is just doing that. So we might just hit the merge button. I think if folks are comfortable, it's the same content as in the additional credentials doc.
Well, there are a few comments from Brendan here. I think that should be resolved before we merge this.
Okay, yeah, so I'll take a look at those. But otherwise, I think this is, once we address the comments, this should be merged. And then we might refactor it before or as part of the refactoring. But this one, as I said earlier, will remain an extension.
Yeah, sorry I missed that. I could have merged that earlier or addressed it earlier.
Just to head off the discussion on this, I put comments in here saying change recommended yes to no. I guess I wanted to ask, do people have thoughts on that? What does recommended really even mean?
Sean, would you like to comment on what recommended means? Since we inherited it from the TLS working group.
I mean, the idea is that it's kind of like it has IETF consensus to be implemented by like everybody, right? It's as opposed to like you can have an extension that's not recommended that goes through some other path, but this one is essentially like fully blessed by the MLS working group.
Yeah, so it's more like it's less like recommended in the sense like we think you should use this, and more in the sense that like the IETF has looked at this and we think it's a plausible thing to do.
And it's got strong. It's like strong and good, and like it's not something that you just half baked up on a napkin and got through the process. Because I believe that the registration rules for this are quite low. And so the idea is, Brendan, that you could write anything, slap it up, send an email, and get a code point for it. And these are meant to be more like it actually went through the rigor of the working groups and the IETF to get all of the review that's necessary. And not everything that goes to the working group needs to have the yes.
So the question is if that argument is good enough for Brendan to retract the requested change.
You could. Okay, sounds good in the chat. Okay.
Yeah, I did leave a comment saying it's okay to ignore those.
Okay. Great.
Alrighty.
I mean, we might just merge if all the conversations are resolved.
There was one thing in there about cipher suites that I'd like to take a look at.
Yeah.
Okay.
Yeah. All right. Cool. All right. So I will Just gonna resolve this one. Resolve that one. Did it merge it? Oh no, it put it in there.
Sorry.
Should put it back. Okay, ignore this. And then I did it. And no. So it stays. Okay, cool. All right, good. All right, cool. So I'll leave that one alone. We're on to number 40. All right.
All right, so that one was me implementing changes that Ayana requested. And Ron had a question about whether or not it was okay to say that these extensions are safe, but then the discussion ended there.
Yeah.
So there are two things to it. First of all, well, targeted messages, we don't know yet what's going to happen to that. And the other question is, do we still have the notion of safe extensions with the new AppSync stuff? I'm not super up to date on that.
That's a good question. Richard?
Sean, can you scroll to the top there?
Yeah, hold on. I'm in too many
Just
friggin'
want to
windows.
see which one we're looking at here.
40. Ayana recommendations, number 40.
Thank you. Yeah, I think this one is going to get clobbered. At least partly. This is just marking the media types as suggested. I would close this.
Well, and safe, right? So that's the
So that's, I mean, yeah, marking it as suggested is what they said. And then they also mentioned that we didn't fill out whether it's safe or not. So this is the point of contention here. I can remove that, of course. I was just wondering if this is then still going to be part of the new AppSync stuff.
Well, some of this will get overwritten by the AppSync stuff, but I think we might as well just merge this one to get the little inconsistencies fixed.
That sounds good. We probably have to rework Ayana stuff anyway.
Yeah. So let's merge it for now. It will be in a slightly better state, and then we'll do further edits with this part of the refactor.
All right.
Sorry, Richard, you are the spokesperson for AppSync tonight. So.
All right. I'm going to merge this one. Whack the button. Done.
Do it.
Sold. All right. 42.
Yeah, we should just close this one.
All right. All OBE. Yeah, all right. So OBE, close with comments. All right, cool. And number 43.
That's a work in progress.
Yeah, so there's nothing to do here.
Start of the refactor.
Okay, cool. Everybody go read it, check it out. A whole bunch is in there. It's gonna have this.
And I did see Rowan in the participant list briefly, but he's disappeared again. So
yeah,
we're not gonna go back to 32.
Yeah, no.
Okay, that's it for the pull requests and issues.
All right, maybe we can get 32 on the list or figure it out. But again, thank you for coming and making this happen. Looking forward to all the edits. I'm hoping that we can get a good AppSync merge, cut, paste, whatever we're doing for Bangkok. Because I guess that's the last question. Should I ask for an hour and a half or 2 hours? At the session in Bangkok.
2 hours.
Yeah.
Sure.
Yeah, we usually end up filling up the time. Things come in late, makes me nervous, but we usually do fill up the time. So thank you very much for your time today. Appreciate everybody dialing in and getting us through this. And looking forward to some revised drafts. Also get those comments in on the combiner draft as well. All right. Thanks, everybody.
Cool.
See you later.
Thank you, everybody. Bye.
Bye-bye. Thanks for taking notes, Conrad.